Sometimes it's necessary to convert data between the two main data models, vector and raster. Here I'll convert the population-based heat map to a vector dataset. Having the data in a vector data model allows for easier area calculations and different cartographic options, such as border and fill, that you don't have with a raster dataset. I'll begin by restyling the town population density raster. Right now we have the default styling, and instead of the single band gray, I'll choose single band pseudo color. I'm going to choose the yellow, orange, red color ramp. And I'll change this to min max, the accuracy to actual, click load, and classify. Now I'll drag the Texas boundary up above, and instead of a yellow border, change that to black so we can see it better. So this is a more pleasing rendering of the population centers, and it's very useful for a visual interpretation. But if I wanted to have an actual layer of these population centers, the heat map needs to be further processed. I'll now identify the highest population centers. To do this, I need to decide on a threshold value that will constitute the population centers. There's a couple ways to do this. I could look at the values from the layer classification in the Layers panel. I could open up the layer properties and look at the histogram tab and try to deduce what might be a good threshold from the histogram. Here I'm going to use the value of 800,000, and I'm going to use the raster calculator. So I'm going to go to the raster menu and open up the raster calculator. I'm going to put my town population density layer in the raster calculator expression window. And I'm going to use a greater than 800,000. I'm going to click the Browse button and navigate to my lab data folder, and I'll call this Population Centers. And change my output format to GeoTIFF. So what this expression will do is for every pixel that had a value greater than 800,000, the output will now have a value of 1, and the remaining pixels will have a value of 0. So we'll have a new raster with two values, those population centers having a value of 1 and the rest of the state having a value of 0. So I'll click OK, and it quickly creates our new raster data set with our 4 population centers that have pixel values of 1 showing up as white. Now I'll convert this output to a vector layer. To do this, I'm going to go to the raster menu again, to conversion, to polygonize, raster to vector. The population centers will be my input raster, and now I'm going to select a name for the output shapefile. I'll call this populationcenters.shape. I'm going to check the box next to field name so that the digital number value, which is what the DN stands for, shows up as an attribute column in my shapefile. It'll be populated with 1s and 0s that my input population centers raster has. I'll click OK. Processing's complete. And click Close. Since this output represents all the pixels in that original raster, I need to eliminate the non-population center polygons from this layer. To do this, I'm going to put the layer into edit mode and select those polygons with a value of 0 and delete them. So I'll right-click on this layer, and from the context menu, toggle editing. And I'm going to open up the attribute table. And I'm going to do a selection. I could simply select this column since I only have 5 rows, but I'll show you how we would actually do this with a SQL expression. We'll click the Select Features Using Expression button, and the Select by Expression window opens. And we'll form our expression in this left-hand pane. So I'm going to expand Fields and Values, and I'll double-click on Digital Number. I'll click Equals, and I can choose All Unique here, and double-click on the 0. I'll click Select, and it selects that record. And I'll simply, in Edit mode, click the Delete Selected Features button to delete those records, and I can toggle out of editing and save my edits. And now I'm left with the 4 population centers as a vector data set. And now that the data are in polygon form, it's straightforward to calculate their acreage. QGIS calculates areas in the units of the coordinate reference system. Therefore, the layer needs to be in a Cartesian coordinate system. If I double click on this layer and go to the General tab, I'll see that this is right now in a geographic coordinate system. So I'll save the layer to a new coordinate reference system. I'm going to right click on the layer and choose Save As. I'm going to choose the output as an Esri shapefile. And I'm going to use the new coordinate reference system in the output name. I'm going to call it Population Centers Albers, because I'm going to put it into an Albers coordinate system. I'll click the Browse button next to CRS to choose my output coordinate reference system. And I'm going to search on the EPSG code that I want, 3083, which is the Texas-centric Albers equal area coordinate reference system. I'll select that and click OK, and click OK. So I now have a new version of my population centers in a Cartesian coordinate system, namely Albers. And now I'll open the attribute table for this new version, and I'll click the Toggle Edit button. And I'm going to add a new column that I can use to calculate the acreages. So I'm going to click the New Column button, and here I have to define the parameters of my new column. So I'm going to call it acreage. I'm going to make it a decimal number column with a width of 7 and a precision of 1. It's important to choose the correct type when you're creating a new column because you can't change it after the fact. Here I want it to be able to hold 1 decimal place, so I'm giving it a width of 7, meaning that this column can store 7 digits of information, and the precision means that it can store 1 decimal place. I'll click OK, and now I'll open the field calculator. I'm going to check Update Existing Field and select acreage as the field to update. So I'm going to expand the geometry column and double click on area to put that in my expression window. I'm going to use the multiplication operator, and here I need to put in the conversion factor. When it calculates the area, it's going to be in coordinate units. So if our expression was simply area, it would calculate the square meters of these polygons, but we want acreages, so we're going to multiply these times the conversion factor from square meters to acres, which is 0.000247,105. And I'll click OK. And now we have acreages for our 4 polygons. In the next task, you'll learn how to go the other way, how to convert from vector to the raster data model.